6-3A, solving quadratic equations by factoring. We're going to use something that you might see in an SAT. Find two consecutive integers whose product is 272. All right, so we're looking for two numbers. What you got to say to yourself, just pick a variable that represents the first number. And consecutive means one right after the other. So if this was 5, to get to 6, I would take the 5 and add 1. So those are our two numbers. Since it says product, that means we're going to go ahead and multiply these two together. So n times n plus 1 inside the parentheses, because this is one number. We know that it's equal to 272. We're going to go ahead and simplify, get rid of the parentheses, and we get n squared plus n, when we go ahead and distribute, is equal to 272. Next up, we're going to go ahead and set this equal to 0, so I'm going to subtract 272 from both sides. N squared plus n minus 272 is equal to 0. We have a quadratic equation, and we've learned that we're using factoring. So we're going to do something as simple as this. We're going to go ahead and use the AC method or diamond. A is equal to 1, so we can just go ahead and straight up say 1 times negative 272. That's A times C. We'll put the B there. We get a 1 there. You're going to have to think to yourself, factors. You might use a calculator. You might use division theory. You know this is an even, so we're looking for maybe an even number. Using your calculator, you get negative 16 and 17 fit the bill. All right, so we're going to go ahead and write our binomial. So we got split the n, or square root the n minus 16 times n plus 17 is equal to 0. All right, our roots or our solutions are here. We're looking for a number that would make this 0, and we're looking for a number that would make this 0, because our final answer is going to be 0. How do we do that? We just go ahead and set both of these equal to 0. And we go ahead and add 16 to both sides, and we subtract 17 from both sides. Well, that doesn't make sense, because if I multiply this together, I might not be able to get 272 because of positive and a negative. So what we've got to think is that there's more than one solution. One is where both numbers are positive, 16 times 17. And also we can have two negative numbers, and that would result in a positive number. So we have 16, negative 16, and negative 17. So right here is our final answer. Not necessarily a normal answer when we were factoring for our roots. It has to do with the problem, what it's asking us for. Our next problem, a little bit more of the same. You can see here it says find two consecutive odd positive integers whose product is 323. We're going to begin with almost the same concept as before. We're just going to go ahead and pick a number to represent our first odd number. If this number was n, was 7, how do I get to the next consecutive odd? Well, what I would do is I would add 2, because 7 plus 2 is 9, so I would add 2. Those are our two numbers. We don't know what they are, but we know that if we multiply them together, because it says product, okay, so I'm going to go ahead and multiply those two together, and that's going to equal 323. I'm going to go ahead and simplify by distributing. N squared plus 2n is equal to 323. I'm going to go ahead and get this equal to 0, so I'm going to subtract 323 from both sides, and I get n squared plus 2n minus 323 is equal to 0. You can see here that we have a quadratic equation. A is equal to 1, so we're just going to simply put it into the AC or diamond method. A times C gives me negative 323, and my B, which drops down here, gives me 2. Now I need to think of factors. that I can multiply to get 323. You can start division theory. You know that you need an odd number here. Take out your calculator, and we get 17 and 19. And because this is a negative, one of these is going to be negative. So when I combine 19 and negative 17, I get 2. So it does work out. I'm going to go ahead and write this as a binomial. So I'm going to split the n or square root it. Negative 17. I'm going to go ahead and put the n and plus 19 is equal to 0. Okay, once again, I'm trying to think of what number would make this equal to 0. Well, go ahead and just set this equal to 0. Do the same here, because we're looking for what number would make this 0. So plus 19 is equal to 0. We're going to go ahead and solve by adding 17 to both sides, and we get 17. Subtracting 19 from both sides, we get n is equal to negative 19. We got to go back to the original problem, and it says positive. So these two numbers, the way they are now, won't result in a positive. So we got to say to ourselves, what do we need? Let's see here. 17 times 19 would give us a positive number. Okay. Or of course we could also think we can't have a negative number because it says positive here. So this is our final answer.